Agnew Jr. I'm a senior computer engineering major from Jackson State University. I'm here at the University of Florida in the ECE department studying cybersecurity. And this summer I had the task of studying network cybersecurity threats. My mentors are Alice Stark and Dr. Janice Agnew. Let's take a look into my lab.
As you can see, I've opened up a command line interface. Right now I'm going into the terminal for the 3 nodes. So for this attack, which is the now service attack, we want to set up a server on one of the nodes and then set up a client to access the server on another node and use the third node to attack either the first node or the second node. For a specific attack, I'll use the third node to attack the second node. So I have these 3 right here. So I will put in this command to initially set up a server for which the second node can connect to. Now we set up an artificial server on Mininet using the command line interface, of course, to bring up the three terminals for the nodes. We set up a simple server on one of the nodes just so that we have something to access while we run this test. And for the second node, I'll use this command to access the server I put on the first node. The 10.0.0.1, that's the IP address of the first node. Now you can use that in the command line interface. You can actually see that when I typed in dumped in the beginning of the video, I was able to determine what was the IP address of that node. And for the third node here, you can see that I'm initiating the attack. Well, I have the attack command inside. I'm going to start that in a second. But first, I want to type it in, make sure everything's set up and everything is good. And as you can see, it's a flood attack. So we're going to flood the second node with a lot of TCP packets. So we have Wireshark here, of course, to record and understand and see what's going on behind the scenes. So here I'm starting the connection between the first node and the second node. So the first node is connected to the second node and vice versa. And I started the flood attack, as you can see here, on the third node. So it's running, they're communicating back and forth. Now we should see a flood of TCP packets into the network. So let's click on one of these to see what's going on behind the scenes. As you can see, there's lots of TCP packets being flooded into the network. And this is going to drastically reduce the amount of packets being sent between 1 and 2. Eventually, you'll see that the packet number, or the rate at which these packets are being sent between 1 and 2, they start to drop to the point where node 2 can't even talk to node 1. So as you can see, just lots and lots of TCP packets. So let's go ahead and get out of this one. And now let's look at some of the graphs. Now I've run these tests before. As you can see, this is the normal traffic. And this is what we expect to see between a normal, healthy traffic between a server and the client. This is what you should see. Now when we have denial service, you see you have this large spike of packets, right? Which is the normal talk, and then all of a sudden you see this huge drop. This is because the client is being overrun with TCP packets, which causes the client to not be able to access the server. Okay, let's go ahead and get right into it. So I have 3 terminals up for 3 nodes. Host 1, host 2, and host 3. Host 3 today is going to be our attack node. Right now I'm going to put in a couple commands which is going to allow me to spoof the IP address of host 3. The whole goal of man-in-the-middle attack is for you to steal information. We do this by inserting one of the nodes in between the traffic between host 1 and host 2. In this case, it's host 3 being the attacker node. Host 1 and host 2 are going to be talking to one another. So as we can continue to put in these commands, we're going to begin IP spoofing. Now we need to use another program called EtherCap to continue the attack. We're pulling up right now, actually. All right, let's go ahead and make sure our environment's set up. We're going to select host 3 as our attacker node, as you can see. Now we're going to scan the network and find our 2 target nodes. Look at our host list. Those IP addresses are for host 1 and host 2 respectively. Let's set those two targets, host 1 for target 1 and host 2 for target 2. Let's check our current targets to make sure that everything's in order. Alright, let's begin ARP poisoning. ARP poisoning allows us to insert ourselves within this traffic. By poisoning the network with these false ARP packets, we're able to hide the identity of host 3 within the network and force ourselves in between the traffic. Let's go on and see what's going on behind the scenes. Let's click into one of these. As you can see here, coming up soon, we have an ARP packet that's being sent on the network. Okay, we're going to let a couple graphs here. Let's look at some of these other graphs for a quick second. This is how normal traffic should look. This is how we expect it to look between a server and a client. But this is how it looks when it's infected. It's pretty much the same. It's really hard to tell the difference right now. But let's look at the server. Look at the normal traffic. It's random, like we expect. When you look at the traffic of the server when it's under attack, it's a pattern. That means somebody is listening to the network. And this is how we can identify it, as you can see here. Now that you've seen the different network cyber attacks, you may ask, what is the significance of this research? Using the data and graphs collected for denial of service and man-in-the-middle attacks, we should be able to detect these attacks sooner. The sooner you detect these attacks, the sooner you can begin mitigation techniques. And time is of the essence to reduce loss of information and damages to the network. Furthermore, we hope to use this information to add an additional layer of security by recognizing the attacks on the network before it even reaches the device. This early detection will better secure our devices in the future.
Wow, that was a lot of work. That's just a small snippet of all the cyber attacks that are out there. I hope you learned a lot today. You got a good insight into my life here at the University of Florida. The University of Florida is a great place, and I thoroughly enjoy my time here. As they always say, go Gators.